Welcome back, guys. This is our last lesson in Unit 1, and we're going to be introducing how to solve a word or application problem, same difference, in Algebra 1. Now, next unit, I will warn you, we are going to be doing a lot of application problems. So just to introduce things and get that conversation started, we're going to do some really basic application problems today, and then next unit we'll really dive into things. So I just want to give you some general steps if you're given a word problem. First, we won't even write this down, but read it, okay? I feel like too many people in math just say, oh, it's words, I don't know how to do it, and they don't even give it a chance and read the problem. Honestly, I might be guilty of that sometimes too. Word problems are not fun because they really challenge you, and they're difficult, okay? They're not as straightforward and easy as the problems we've been doing, so please read it. After you've done that, you want to define your variable. So like P equals people, B equals books. Whatever you're trying to solve for, you want to give it a letter and tell me what that letter stands for. Then you're going to write an equation to represent the situation that's going on. We're going to use algebra. Algebra is writing equations and solving for variables. Okay, so we're going to put all of the information together in an equation that makes sense, and then we're just going to solve that equation for our variable. All right, so this is algebra in real life, people. Don't we love these? Now, I'm also going to point out, and I'm not going to write it as a step, just like I didn't read the problem as a step. That's kind of like a duh thing. But I want to point out that it's really useful to underline things in the problem, highlight things in the problem, circle stuff that's important. So I'm going to do that as I read. So let's just jump right in. Practice problem A, it says the sum. So let's see, I'm going to make notes. I know that sum means add. So if I add Jane's age and Sarah's age, if I add those two girls' ages together, that should be 33 years old. Now, we've seen the word is before, and I want you to make a note if you would have forgotten, but is means equals in math. Okay? Then they go on and they tell me, well, Sarah's 15. Okay, obviously that is important. Any number in the problem should be used when you do step 2, write your equation. So if Sarah's 15, how old is Jane? First thing you want to do is define your variable. The question, you guys, that tells you what your variable is. Think about, what are you being asked? What are you trying to find? How old is Jane? Okay, well, I'm going to use J for Jane's age. That's what I'm trying to figure out. So I've got my variable defined. You should do that. Then I want to write my equation. So come back to like the first sentence, the sum. Well, I knew that that meant add. If I add Jane plus Sarah, I don't know Jane, so that's where I'm going to use my variable. I do know Sarah, though. She's 15 years old. So if I add those girls together, that should equal 33 years. So pretty straightforward equation once I've written it. Hopefully it's super easy to solve from here. It's just a one-step equation, which all of you should be able to do. So I'm just going to get J by itself. That's the goal. I'm going to subtract 15, and that would give me Jane is 18 years old. Yay, algebra in real life. Isn't that fun? All right, I want you guys, so kind of jump into it right away. I want you to do example B. If you want to skip it for now and watch me do the rest and then go back after you've done a few more practice problems with me and try it, that's cool. If you feel like you can do it right now, pause the video and try it now. That's totally your choice, but I want you to try B. For practice example C, it says at Max Middle School, there are 30 times, so I'm going to underline, 30 times as many students as teachers. If there are 450 students, obviously all numbers are important, how many teachers are there? Okay, step 1, define your variable. Look to the question. They're asking me how many teachers. So T is what I'm trying to find. And you can use a T, but I would like curve it at the end so it doesn't look like a plus sign. All right, I know I need to write an equation, so it has to have an equal sign. I need to use t, I need to use the two numbers in the problem and put it all together, something that makes sense. So think about it. And that's what people, I think, overlook in word problems. Think about if your answer or what you're doing makes sense. All right? If I would have gotten that Jane was 118 years old, yeah, that's probably not realistic. Or if Jane's -5, that doesn't make sense. Okay? So think about an answer that makes sense. Just like in this problem. I think to myself, are there more teachers or more students? Well, there's 30 times as many students as teachers. So there's more students here. And I'm going to make this note. You don't necessarily have to, but if I think to myself, what's going on here? Because this one can be a little tricky to write. There are more students than there are teachers. Okay, so I've got to work t in, so I'm going to throw that on one side of the equal sign. If I take the number of teachers, there's more students than teachers. If I take the number of teachers and I multiply it by 30, that's what they mean when they say 30 times. If I take the number of teachers and multiply it by 30, that gives me how many students there are. Since there's 30 times as many, well, they told me how many students there were. There was 450. So that's what I'm going to set it equal to. Okay, and once I've done that, hopefully, again, it's a one-step equation. I just need to divide by 30 on both sides, and I've got my answer. So 450 divided by 30, and you'll get your little basic calculators on your exam, but that would give me 15 teachers. And again, think about if it makes sense. If you get that there's like 800 teachers at this school, that does not make sense. There's always more students than there are teachers in a school. Okay, so think about your answer before you move on. All right, example D says a scuba diver dove 16 feet, all numbers are important, to an elevation of -50 feet. That makes sense. Negatives are going to happen when I'm like diving in the ocean. What was her elevation before the dive? Okay, so to define my variable, I look to the question. What was her elevation before the dive? So I'm going to use E. And that stands for what I'm trying to find, which is elevation before the dive. And I'm going to put all that together into an equation, so it's got an equal sign. Again, think about the situation. Well, her elevation before the dive, what did I do to that? Well, she dove 15 feet, so here's my lovely art skills. You will learn this semester, you guys, that I am not very good at drawing. But let's say that this scuba diver is, she's down here in the water. This is below the water. And she dives down 16 feet. And she ends up at an elevation of -50 feet. Okay, I want to know, where did she start? Well, if she goes down, she's going to be subtracting 16 more feet onto her elevation of where she's at, and she ends up, so that's what's going to equal, -50 feet. Semi-embarrassed about my drawing, but whatever, you get the idea. Pictures help. So to solve this, I just need to get E by itself, so I'm going to do the opposite and add 16 to both sides. Be careful with your negatives and positives here. -50 plus 16 is -34 feet. Okay, so she started at -34 feet. All right, on to the back. Now, honestly, I'm going to go against my own rules here. If we're just thinking like pure problem solving in real life, I want you to realize that sometimes, you guys, when you're solving a word problem or like trying to figure out the answer to a situation, it actually might be easier to not define a variable and write an equation. I know, I'm totally contradicting what I said on the front side of your notes here. But let's be realistic, okay? If I'm in a situation in real life and I'm presented with a problem, I'm not going to be like, oh, hold on, give me my pen. I need to define a variable and I need to write an equation. Yeah, that's not always realistic and it's not like quick thinking. Sometimes it's easier not to do that. And figuring out a problem in a real world situation can be a lot simpler by, here's a thought, just using your brain. Smiley face. sometimes just thinking through it and using your brain and not necessarily algebra skills is more useful and more realistic. Okay, so sometimes, and maybe on the exam I'll do this just to kind of see your problem solving skills, but sometimes I might not say define a variable and write an equation, which is what I would have said on these front examples. Sometimes I'll just say, hey, figure this out. I don't care if you like make a list or you just kind of like write down notes. I don't care how you figure it out. Maybe you just punch stuff in your calculator, honestly. That's what people do in real life. I just want to see your problem solving and if you can figure something out like this example here. So here's the problem. It says a bakery owner turns on his donut machine at 8:30. At 11:10, the machine has completed 1/3 of the day's job. At what time, so I want to know what time, so you should give me an answer like 2:45, something like that. At what time will the donut machine complete the job? All right, here's what I would do. I would figure out, let's see, I know 1/3 of the day's job was done between these two times. So I got to figure out what's this time frame right here. Well, I feel like most of us could do that. From 8:30 to 11:10, let's see, 2 hours after it was turned on, that'd be 10:30. If you had 40 more minutes to that, you'd be at 11:10. So, all right, I'm going to just make some notes so I can figure this out. Here's problem solving in real life, people. After 2 hours and 40 minutes, 1/3 of the day's job was done. That's the time span here. Well, I know for the full job it needs to be 3/3. So if I add on another 2 hours and 40 minutes, that would be 2/3. If I add it on again, that would be the complete day. Okay, so I broke it up into thirds. There's one, there's another, there's another. So I basically need to go from 11:10, it's kind of where I'm at right now, and I need to add on 2 hours and 40 minutes and then 2 hours and 40 minutes. Okay, so if it's me, I'm just going to combine these 2 hours and 40 minutes and figure out the total time I need to add on to 11:10 a.m. So let's see, that'd be 4 hours and 80 minutes. Let's see, I want to convert this into like full hours and minutes left over. So let's take 60 minutes away from this guy and add on 1 more hour. All right, so realistically, you guys, I need to add on 5 hours and 20 minutes. And you do not have to write exactly what I'm writing, okay? I feel like a lot of you, maybe you wouldn't even write anything down, but for the sake of like me teaching you how to do this example, I'm gonna write some stuff down. I need to add on 5 hours and 20 minutes to my time here. So here's what I would do. Let's add on the 20 minutes, and that would put me at 11:30. Then I need to calculate 5 hours from there. Honestly, use your hands. So if I'm at 11:30, I would go 12:30, 1:30, 2:30, 3:30, 4:30. If I'm counting 5 hours. So at 4:30 p.m., that's when the donut machine has completed the full day's job. All right, so that's an example of like more so real life problem solving, where maybe algebra isn't the best thing to use. Maybe just using your brain and making notes and figuring it out is the better way to do it.